Okay, so here is your review on sequences and series. So there are two main kinds of sequences and series that we study. They are not the only kinds of sequences and series, and some sequences may not fit either of these. But there are the two that we focus on are arithmetic, and it's spelled like arithmetic, but it's pronounced arithmetic, and geometric. Now, in an arithmetic series, we're adding the same common difference each time. So in this example, 7, 9, 11, our common difference is 2 because we're adding 2 each time. We can also go from a bigger number to smaller numbers, and we don't think about it as subtracting, we think about it as adding a negative. So to go from 5 to 2, we would add a -3, and to go from 2 to -1, we would add a -3. So our common difference, it can be positive or negative, and it's what we're adding each time consistently to get the next term. Now with geometric sequences, we are multiplying to get the next term. So what we would multiply 2 times to get -8 would have to be -4. And that is what we call the common ratio. So for arithmetic, it's the common difference. For geometric, it's the common ratio. And then we can check our work. -8 times -4 would give us a positive 32. So a lot of times when that common ratio is negative, you'll see that sign flip-flop. In fact, you'll always see that sign flip-flop from positive to negative, positive to negative. Now, when we look at the second one, it's also geometric, and we're multiplying by the same thing each time to get the next term. But a lot of people want to say, oh, well, we divided by 5 to go from 100 to 20. We're not going to think about it as dividing by 5. We're going to think about it as multiplying by 1/5. And so again, the common ratio, it can be positive or negative, and it can also be a whole number, or it can be a fraction if we're dividing. Now these four sequences I have laid out, those are sequences because it's just a list of a pattern set of numbers. But if I wanted them to be a series, instead of having 7, 9, 11, I might say 7 plus 9 plus 11 plus ... Okay, so series are the sum of all the items in a sequence, and so we write it with our addition symbols between our terms. So each of these that I'm writing in white would be series, whereas the ones in pink are the sequences. Okay, let's look at the formula. So here I took this from your formula sheet. You have two equations you'll see here for arithmetic sequences and series. Okay, when they say the sum of n terms of an arithmetic sequence, this is also, we could refer to it as the series formula. Okay, and then we have our 3 formulas for geometric. Okay, and this one would be a series here. Okay, so a couple things we have to talk about in terms of notation. N always is going to represent the number term we're talking about. Another way to say that is its place number in line. Okay, so is it the first term? Is it the 10th term? Is it the 11th term? Which term is it? And so that's its number in line. Okay, not the actual value of it, but which spot it's in. U sub n is the actual value of the term. And that's true for all of these equations. So, for example, if we have a sequence that goes, let's say 2, 5, 8, and so on. Okay? U sub 2 would equal 5 because the second term, the nth place in line, the second place in line is 5. Okay? So n is 2, U sub n is 5. This is very similar in style to our function notation, which looks like this, like f of 2 equals 5. When x is 2, y is 5. Same idea, when n is 2, the term is 5. Okay, so very similar to that notation. Now, what about s sub n? Okay, s sub n represents the sum of all the numbers up until that term. So the sum of the first n terms. So let's go back to that example I had before, the simple one. Let's say I wrote s sub 3. Well, first of all, u sub 3, the third term, would be 8. The difference between u sub 3 and s sub 3 is that s sub 3 would be the sum of the first 3 terms. So it wouldn't just be 8, it'd be 2 plus 5 plus 8. Okay, so that would be 15. So s sub 3 would be 15, the sum of the first 3 terms. U sub 3 would be 8 because the third term is 8. So that is how our notation pretty much always works, looking at our formula sheet right there. Let's see if I can get this zoomed out for a second. There we go. So looking at this, we have these two formulas for arithmetic sequence and for series. D is the common difference. N is which term you're talking about. U sub n is the value. S sub n is the sum of the first n terms. Now, if you notice, you have the formula written out in two different ways. It doesn't matter which one you choose. It just sometimes one might be easier than the other. Now for geometric sequence, remember in class we talked about how this relates to exponential functions because it is an exponential function, the common ratio r to the n minus 1 power. Again, s sub n is the sum of the first n terms. Now, we can actually sum to infinity terms that have a common ratio with an absolute value less than 1. So this is the qualifying factor to be able to sum to infinity. Okay, so let's go ahead and look at some examples. So it gives us an arithmetic sequence and it asks us to find the common difference. So we might say, well, 9 minus 3 is 6. So that's our common difference. D is 6. Then it asks us to find the number of terms in the sequence. Okay, now this is a common problem. I've seen this kind of problem a lot. They tell us the last term. If that last term is the 12th term, then there's 12 terms in the sequence. If it's the 100th term, there's 100 terms in the sequence. So when they ask us to find how many terms are in the sequence, they're really asking which term is 1353. Now, we have to decide, is 1353 the n or the u sub n? Well, n is which term it is. U sub n is the actual value of the term. The value of the term is 1353, so u sub n is 1353. So we can actually substitute in to this formula that is for arithmetic sequences. U sub n is 1353, u sub 1 is 3, n is what we don't know, but we know the common difference is 6. So now we're going to solve. Subtract 3, we get 1350 equals 6 times n minus 1. Divide by 6. And so we get 225 equals n minus 1. So n is 226. So there are 226 terms in the sequence. Lastly, it says find the sum of the sequence. So if there's 226 terms, then we're going to sum all 226 of them. So n is going to be 226 because we want to find s sub 226. And so I am going to substitute straight in to our s sub n formula. S sub n equals, and we can use either of the two formulas. In this case, since we do actually know what u sub 226 is, we may as well do the shorter equation, n over 2 times u sub 1 plus u sub n. So if we're trying to find the sum of 226, that's going to be 226 over 2 times u sub 1, which is 3, plus u sub 226. Well, the 226th term is 1353. If we did not know what u sub 226 was, it would be easier to have used the other one that didn't require you to know u sub n, and you could instead use the common difference to find that. And so all we're going to do is calculate that out on our graphing calculators. And so we get the sum of the 226 terms is 153,228. Okay, so let's look at another example, this time with a geometric sequence and series. So it tells us the first term and it tells us the fourth term. And it asks us to find the value of r. Now, we could do it a couple different ways. The easiest way is to figure out how many times are we multiplying by r to get from the first term to the fourth term. And so sometimes I just like to write it out like this, if it's short enough. The first term is 1 over 81. The fourth term is 1 over 3. Well, how many times are we multiplying by r? We're multiplying it by 1, so it would be 1 over 81 times r. And then we'd multiply by r again to get 1 over 81 times r, or r squared. And then to get to the fourth term, it'd be 1 over 81 times r times r times r, or times r cubed. Well, we know 1 over 81 r cubed must equal that 1/3. And so we just have an equation we can solve. Now, another way that we talked about doing it in class is to substitute 1 for n and 1 over 81 for u sub 1 and 4 for n and 1/3 for u sub 4 and solve a system of equations, but I feel like this way is much faster if you have the opportunity. Anyway, so we're going to go ahead and multiply by 81. And so we get r cubed equals 27. And we're going to take the cubed root, and so we get r must be 3. Then it says find the smallest value of n for which s sub n is greater than 40. So I'm going to use my s sub n formula, which says u sub 1 times r to the n minus 1 all over r minus 1. So we're going to substitute in what we know because we want that to be greater than 40. Okay, so u sub 1 is 1 over 81. R is 3. And so 3 minus 1 is 2. So we substitute in what we know, and then we're going to go ahead and solve. So it's greater than 40, so multiply both sides by 2. So that's got to be greater than 80. Now multiply by 81. And so we get 3 to the n minus 1 has got to be greater than 6480. Add 1. And look at that, like we've talked about, everything is together, so now this problem has turned into an exponential equation that we're solving, and we have to use logs. So we take log base 3 of both sides. So on the left, that leaves us with n, and on the right, that leaves us with 7.9886. And so the smallest value of n, where the sum is going to be greater than 40, would not be until n was 8. Okay, the next problem we have is an infinite geometric sequence problem. So the first thing it asks us to do is to find the common ratio. So what are we multiplying 3,000 by to get negative 1,800? Well, I would just say, let's go ahead and divide negative 1,800 over 3,000. And we can go ahead and simplify that number into a nicer fraction of negative 3/5. And so that's our common ratio. Then it asks us to find the 10th term. Okay, so we're trying to find u sub 10. And so we're going to plug into the formula, which says u sub 1 times r to the n minus 1. So u sub 10 would be 3,000 times r, which is negative 3/5, to the 10 minus 1, or to the 9th. Okay, so 3,000 times negative 3/5 to the 9th, and that gives us our 10th term is rounded to 3 sig figs, negative 30.2. Then it says, find the exact sum of the infinite sequence. So there's a difference between summing the first 10 terms and summing the infinite sequence. If it asks us to sum the infinite sequence, we're going to use the sum to infinity formula. And all that says is u sub 1 over 1 minus r. We can only find a sum of an infinite sequence if the common ratio is, if its absolute value is less than 1. So absolute value of negative 3/5 is 3/5, and that is less than 1. So we can find the sum to infinity. The first term is 3,000, 1 minus negative 3/5. Okay, and so that's 1 plus 3/5. And so we can solve that out to give us the exact sum, which is 187.5. Or if we wanted to write it as a fraction, we could say 375 over 2. Okay, let's look at one last problem. In this problem, they tell us what u sub 21 is, and they tell us what u sub 4 is. And so this is one of the situations where we could do it kind of like the problem we did with our geometric sequence, where we figured out how many times we'd have to multiply r by, and then we set that equation up. But when it gets really spaced between the 4th term and the 21st term, we can go ahead and do it a second way, which is using a system of equations. So what I might do, since it's arithmetic, is I'm going to write out the formula for an arithmetic sequence. And what we might actually do is plug in what we know into 2 separate equations. So in one case, we know that when n is 21, u sub n is negative 37. And, I'm sorry, I just wrote that in wrong. U sub 1, we still don't know. N is 21. Okay, sorry about that. So the things that we don't know the first term and we don't know the common difference. And then we can go ahead and set up a second equation, same idea, that when n is 4, u sub 4 is negative 3. Okay, this is just a system to solve. Okay, so we're going to simplify. Negative 37 equals u sub 1 plus 20d. And negative 3 equals u sub 1 plus 3d. And so you can solve by substitution or elimination. So let's say I solve my second equation for u sub 1. I can then go ahead and plug it into my first equation. And go ahead and simplify. So negative 37 equals negative 3 plus 17d. I can go ahead and add 3 to both sides. And so I have negative 34 equals 17D. Divide both sides, and I get -2. And so I get my common difference to be -2, sorry. The next thing it asks me for is it asks me for the first term. Well, once I know my common difference, I can go back in to one of these two equations and plug it in for D and solve for U1. So -3 equals U1 minus 6. I add 6. I get my first term is 3. So that's an example similar to the last one where we this time solved it with a system. Now the very last part of this one asks us to find S sub 10. All we're doing here is plugging and chugging, okay? So S sub 10 equals, now we don't know the 10th term, so I'm going to recommend us to use this formula for our arithmetic series because we don't know what S sub 10 is. And we can plug in everything we know. 10 is N. The first term is 3. 10. N is 10. I just didn't write that. Okay. And our common difference is -2. So all we have to do is finish solving here. That's 5 times 6 plus 9 times 2, which is -18. So that's 5 times -12. So that's -60. And that's our sum of the first 10 terms. Hopefully that gives you a pretty good review of sequences and series. This is similar to probability in that there's a bunch of different ways they can ask these problems. So I really recommend you look at your practice, your past tests, hopefully you kept them, or at the book, or come see me for extra problems.